Hey there, universe nerds! Today, we're diving into one of the most mind-bending ideas in all of modern physics, the holographic universe. It sounds like science fiction, but it's a real scientific theory that could change how we understand space, time, and even reality itself. The idea is simple to state, but staggering to grasp. Everything we experience, all of space, matter, and energy, might actually be a projection from information stored on a distant two-dimensional surface. In other words, our entire 3D universe could be a hologram. Let's start with where this bizarre idea comes from. It began with black holes, those mysterious objects that seem to swallow everything, including information. In the 1970s, physicist Jacob Bekenstein noticed something strange. The entropy, or information content, of a black hole wasn't proportional to its volume, as you might expect, but to the area of its event horizon. Then Stephen Hawking confirmed that black holes have temperature and emit radiation, meaning they can eventually evaporate. But that led to a paradox. If a black hole disappears, where does all the information go? Quantum physics says information can't be destroyed. It must be preserved somehow. That's where the holographic principle was born. Physicists Gerard 't Hooft and Leonard Susskind proposed a radical solution. Maybe all the information that falls into a black hole isn't lost. It's encoded on its surface, like data on a hard drive. The 3D interior might just be a projection of 2D information on the horizon. If that's true for black holes, they argued, maybe it's true for the entire universe. Everything we see around us, stars, galaxies, even you and me, could be the 3D manifestation of data imprinted on the edge of the cosmos. It's not that we're living in a computer simulation, though that's another fun idea. It's that the fabric of reality itself might work in holographic terms. In the 1990s, the theory gained serious traction thanks to a breakthrough by physicist Juan Maldacena. He discovered a mathematical correspondence known as the ADS-CFT duality, a relationship between two different kinds of physics: gravity in a higher dimensional bulk space and quantum field theory on a lower dimensional boundary. In simple terms, it means that everything happening inside a region of space-time can be fully described by information living on its surface. It was the first concrete evidence that the holographic idea might actually be true, not just metaphorically, but mathematically. What's beautiful about the holographic principle is that it unites two of physics' greatest frameworks, quantum mechanics and general relativity, in a single picture. Gravity, which governs the geometry of space-time, might emerge from quantum information encoded on a lower dimensional surface. Space itself could be the result of entangled information. Reality, in this view, is built from the bottom up by data, not matter or energy, but information. It's as if the universe is one vast self-rendering code projecting space-time from the boundary inward. And here's the really trippy part. If this principle holds, then what we experience as real, solid, physical, and three-dimensional, is a kind of emergent illusion. The deeper structure of the universe might not exist inside at all, but on the surface. Every star, every particle, every moment of your life could be a holographic pattern of quantum bits on the cosmic horizon. Even time itself might be an emergent property, not something that flows, but something encoded. The now you're experiencing might just be one frame in an infinite projection. Of course, the holographic universe isn't something scientists can observe directly, at least not yet. But there are clues. Experiments like the holometer at Fermilab have tried to detect holographic noise, tiny vibrations in space that could indicate the universe's fundamental discreteness. So far, nothing conclusive. But on the theoretical side, the holographic principle keeps proving its worth. It helps physicists model black holes, understand quantum entanglement, and even explore the nature of dark energy. It's not just a wild idea, it's a useful one, with equations that actually work. Philosophically, though, the implications are staggering. If the universe really is holographic, then reality is information first. Physical things are secondary, like the images on a screen that only exist because of the data behind them. It suggests that consciousness, matter, and space-time are all part of a grand informational network. The universe doesn't just contain information, it is information, constantly processed and projected into what we perceive as reality. So, what is the holographic universe? It's the idea that the world we see, vast, complex, and three-dimensional, might be a shadow cast by something simpler, deeper, and beautifully mathematical. It's not saying we live in a fake world, but that reality might have more layers than we can perceive. Every star, every atom, and every heartbeat could be a line of code written on the boundary of the cosmos, projected inward as light, matter, and life. The holographic principle reminds us that the more we learn about the universe, the more mysterious it becomes. The closer we get to understanding everything, the more we realize maybe there's another dimension to the truth itself.